Okay, so yeah, those are the calculations, and watch this. I can make them magically disappear to reappear upon my wish. We'll leave that up there. I'm afraid if it all goes away, it might not come back. Okay, so the nuts and bolts of what you're doing today. Honestly, I feel a little bit, because I really think you should be wearing goggles. Part of me thinks that, but the other part's like, it's sugar water. You know, though, I'm making up by next week, you'll be using fire, Bunsen burners. So yes, you need to wear your goggles next week, okay? Yes. I know. I don't like fire, but that'll be fine. So you've had a chance to look over today's lab, and I'll kind of talk you through it. Oh, and don't forget, there's a pile up here. Don't forget your lab write-ups are due today or by 10-ish or so tomorrow morning, okay? So that's kind of, and if you want me to look at it before you hand it in, that's cool too. The other thing is, after we get started, I do have your graded assignment that you turned in on Friday. So I want to give you back your graded assignment. If you see something like show work and that sort of thing, but you still went ahead and I gave you most of the credit, know that if this was a test, and because we're still kind of finding out what I mean by show work, okay? If this was a test and you didn't show work, it'd be a lot more brutal than only taking 1 out of 10 points away.
You get the correct answer, but you don't use the way that you told us to do it. Is that still correct?
In general, you probably get like a third of the points if you just get the, wait, I guess there's
like
two.
You put in the equation, but it's not like the way that you did it, you know, like
Oh.
the crossing out and the slashing and everything.
Oh yeah, you know you have to cross out and slash. You have to do that factor label thing with terms, with units canceling. The other way that oftentimes people have been taught to work problems is the ratio, you know, and something over x is equal to, you have another ratio over there. We're not doing that. That doesn't get you down the road to where you need to be. Honestly, it's not because I'm being cruel, okay? But in another way, if like I set up a problem using factor label and you set up your problem differently using factor label, those are both cool.
Okay.
So, yeah. So anyway, I'm going to hand those back while you guys get started working. Okay, so today it talks about the 4 beakers that you'll need, the A through D beakers. And so I have these cute little Erlenmeyer flasks over here. Okay, and they are in sets of 4, so A through D, A through D, A through D, etc. That's what you'll be doing, and they're already marked for you. And number 2 is you're supposed to have a tare weight on each of these. So there's a place for you to write in your permanent lab notebooks what the tare weight is on your A through D, all right? Next it says the thing about the sucrose, step number 3. So the sucrose is sugar, right? And it is this white stuff. I know that, like I worked in the at the Iowa Army Ammunition Plant in their chemistry lab as a technician. I know, it's awesome. And I didn't blow anything up, although I really was in a place where I could have at one point. But so my point is, when you work in a lab, they never leave beakers like this around with unmarked. So this kind of goes against my grain. I'm hoping you guys all know this is sugar though. So you take one of these back to your desk, and it says that you want 2 grams in A, 4 grams in B, 6 grams in C, 8 grams in D. Okay, so you have a tare weight on all of these. It says that your instructor will tell you approximately how much a scoop is. I'm going to write it over there, but 1 scoop is about 1/2 gram. So if you want 2 grams, how many scoops do you need? 4, exactly. So 1 scoop equals 1/2 gram. So you go ahead and you'll have those at your desk, and hopefully nobody will interrupt you while you're scooping. Okay, 1 scoop equals approximately 0.5 grams. So then your instructions are to go ahead, once you have your A through D, your sugar in there, go ahead and take them back and weigh them again. There's a place in your lab notebook to put your flask plus your sugar. Okay, flasks you have a tare weight on. By difference, then, you know the mass of your sugar, right? Right? So that was steps 3 and 4. Steps 5, basically you're going to juice up your A through D, okay? So here's where and you'll see why it doesn't really matter. But it gives you a range of water to add. It says add 30 to 40 milliliters of water to A through D. Okay. Two things after you get it juiced up. One thing is you're going to want to make sure before you do anything with your solution, it's homogeneous, nice, and make sure that sludge goes away. And the other thing before you do the next step is you want to get a weight on this. Okay, so now it has sugar, your component of interest, and water. Okay, so it's a solution. Okay, so get a mass of that. Write it and record it. Then you have your solutions ready to work with. The part two part is you're going to get to have a dedicated, cute little 50 ml beaker. Okay, so for all of your trials, and you're almost done, by the way. Part two is important, and you're almost done. So part two says get a 50 ml beaker of your choice, get a good tare weight on it, and you can use that same tare weight for these different measurements, and you'll see what I mean. Okay. Then it says to go ahead and take water, not that solution, but take water, and you guys practiced pipetting last week. Okay, and use this one of these 10 ml pipettes to go ahead and transfer deionized, an aliquot of deionized water to your weight beaker. Okay, it's kind of like what you guys did last time. Then go ahead and weigh that back, and by difference you have the mass of your aliquot of water. So it is what you did last week, wasn't it? But you only have to do it once instead of a bazillion times, right? Okay. So you have the mass of that recorded. Go ahead and dump that out. Make sure it's good and dry, because what you're going to do is turn your attention to your 4 solutions that you prepared and do the same thing. Okay, A through D. Each time using a dry beaker, transfer using a pipette, that 10.00 milliliter aliquot of your solution, weigh it back, record it. Dump it out, rinse it out, dry it out, go on to the next solution. It's very common. What you're doing is you're always stepping up in concentration, because, right, you went 2 grams, 4 grams, 6 grams, 8 grams, right? And that's really standard. So that if you have any carryover between samples, it's less of a problem than if you go 8, 6, 4, 2, because you're going to have more of a contamination issue possibly. Just the way it works out. Okay? So you have masses of those. You can go ahead and then, just like you did in your calculations here a minute, you're going to calculate the density of water again. And you're also going to calculate the density of your increasing sugar concentrations. So what do you think? As you increase the amount of sugar you have for 30 to 40 mils of water, what do you think should happen with regard to the density? How many people think the density will increase? Me too. This is a good place to look. Does the data make sense? Okay. It should increase. Okay, so, oh yeah, one last thing. So, see, that shouldn't take very long. Not that it's a race or anything. So actually the coup de grace, and I'll kind of point out that this needs to be in your calculations, is you're going to use your data that you came up with regard to density of sugar solutions to calculate the density of sugar in these 2 solutions over here. I'll make it quiet in there. I like that sound too. Okay, so these are 2 soda pops. Okay, and honestly, I don't know which is which. Okay, they're 2 soda pops. One is diet and one is not. Have you ever heard that, like, soda pop is basically, normal soda pop is basically sugar water? Okay, and we're going to kind of count on that. So I'm going to show you in a minute how to make a calibration curve basically with the data from your known sugar solutions. You're going to use that to make a calibration curve. Then you're going to find these densities on that calibration curve. So the last thing you need to do, and it's labeled Part 2, item numbers 9 through 12. Oh, sorry. Part 4, item number 13, is basically you need to use that 50 ml beaker that you've been using, okay? And then you need to transfer a 10.00 milliliter aliquot of these independently and get the mass of that aliquot and record that, okay? That makes sense. Okay, so let's take a look at your calculations. So your calculations go like this. Okay, calculation 1 for the first part is to calculate the weight percent of sugar in each of your A through D. So you did it 4 times, right? You got the mass of sugar by difference from subtracting the mass of the empty beaker or flask from the mass of the sugar plus the flask. That goes in the top. You'll need the total mass of the solution. Remember, after you juiced them, you weighed them back too. You have lots of weights in this lab. After you added your 30 to 40 mils of water, you weighed them back too. So you have the total mass of the sugar and the water. That number goes in the bottom. Okay, to get it parts per 100, multiply by 100%. So do that for A through D. The next part is pretty simple, like deja vu, right? So for that, just one simple, take some deionized water, which you should use for your juicing up of your sugar solution. Take deionized water, use your pipette, transfer a 10.00 milliliter aliquot to your weighed 50 ml beaker. Weigh it back, okay. You got the dot down from last time. So you weigh it back, your beaker plus your aliquot of water. By difference, you get your mass of your water, and divide it by, it's always going to be a volume of 10.00 milliliters. Okay. Then you need to do a similar thing for your sugar solutions that you prepared. The next parts of the calculation, I'm going to pull up Logger Pro. Okay, but this is the last one on paper that you need to put hand in. So last but not least, remember that you used the, say last but not least, there's one more. No, there isn't. Last but not least, you used your 50 ml beaker to go ahead and receive aliquots of A through D. Go ahead and from that mass, divide it by 10.00 milliliters and see the increasing densities like you expect it should be. I'm sure I didn't miss a calculation. Okay, that's 3. Yeah, and calculation 4. Okay. Let me go ahead, if you see in your notebooks, like I am, let me go ahead and add something up here. If you look ahead to calculation 6, that actually, oh darn it. Oh, by the way, my laptop came back up again. You know what it was? Is aside from it just having kind of a terrible crash, I had a DVD in the reader. So every time it was trying to reboot, it saw that DVD and it wasn't a boot disk, so it was very mad. Heck yeah. What I was going to say is number 6, while I'm thinking of it, is very similar to number 3. Okay, so for calculation 6, basically all you got to do is for your for those two over there, calculation 6 is for those two over there, your 2 pops, one's sugar and one's diet. You basically take the mass of the mass of the aliquot. I love that word, divided by 10.00 milliliters. And that will give you the density. These are what we're calling our unknowns, density of unknown. And I didn't yet, but I'm going to call them from left to right unknown. I better call them 1 and 2. Unknown 1 and 2, because we already have A and B. Left is 1, right is 2. Okay, so let's take a look at Logger Pro. I haven't heard anybody squawk about Logger Pro yet. Is it like working for you, or? Okay, you don't know yet. You're going to need Logger Pro for this one. Okay, so, but I did talk to Barb Altide, who does the computers around here. She's great. And in the computer lab, there are a set of, I already have it open. In the computer lab, there are a set of maybe 4 computers against the wall when you first come in by the person who's sitting at the desk in 417, I want to say, the computer lab. And this program is installed on those computers. So if you just want to do it, use those computers there, that's fine, because you can print from the lab too. The other thing is if you have it, you do it at home and you want to print it out, you can bring it here and print it out. The other thing is I also have it on this one, so you're always welcome to this one. And in a pinch, students will say, Mrs. Snipes, can you print this out for me? And of course, I can't say no. Okay. So welcome to Logger Pro. I mentioned it's kind of like a Excel spreadsheet. Can you kind of see the spreadsheet part over here, the graph part over here? So specific to this lab, and you're just going to want to play around with it. There's a lot of things in electronically, especially in life, that you just want to play around with. But it says, for instance, well, there's a lot of blah, blah, blah. I'll kind of tell you as we go along. But it says that you are going to, along your x-axis, you're going to put your densities. Sorry, along your x-axis, you're going to put your weight percent of sucrose. So did you guys see what I did? I just double-clicked on that X and this came up. It's kind of, your lab manuals actually have kind of some nuts and bolts of how to use Log or Pro or Ask Me. So I'm going to label that as weight percent. Ugh, you know what I mean. Units, I probably just won't get too fancy. Done. This one right here, I'm going to label this as density. Okay, because I want to just kind of show you the ordered pairs that we're going to end up with. So what's the weight percent of sugar in that water? 0. Hopefully, you know, if it's pure, there is none. Okay, so your first sample, actually, the weight percent in plain old water is 0. And then I honestly can't remember what the weight percents run. So I'm gonna go from A to D. I'm just gonna come up with some fictitious percents, so just bear with me. So let's just say we went 10%, 20, 30. A common mistake I've seen students do is try to put an alpha, they want to put like 30 mils or something. They want to put a character there. It has to be a number. If it's a character, this spreadsheet won't recognize it as a number. You'll see what I mean, it's flat lines. Okay, so you guys told me the density will increase as our percent increases. What's the density of water, grams per mil? 1. So we'll see how close you get to that today. Let's see, do you guys see that? I'll show you how to fix that. Did you notice how I put in 1.00 and it went to 1? You're like, dude, we emphasize in here, it's not 1, it's, you know, no, at least a 3 safe things. I'll fix that in a minute. Then we're going to increase, so I'm going to put 1.010. I'm not going to be very creative. 1. Well, I better do something here. 10, 1.3, and 1.5. Going to get a little bit of scatter there. Okay, a lot of scatter. Can you see down here where it is plotted my five dots? It's pretty ugly so far, doesn't it? This is where you get to play around with it a little bit. I'm going to show you how to fix this, okay? But you got to do it yourself. So one of the things you know is wrong about it is I really need to use more of my y-axis, don't I? Okay, we can fix that. You can basically fix anything if you do a right click and click graph options. Okay. X-axis options. It should have been doing an auto scale for Y auto scale. I'm not sure what the auto scale larger meant, but I'm going to go plain old auto scale. Let's see if we like that any better. I'm liking that a little better. Okay, so you're getting the ideas. If you want to fix it, which we do, we need to, there's a way to do it, and I don't want to take all your time. I don't want to take all the fun doing it for you. You need a title, you'll figure out that under graph options and all that sort of thing. While I'm here though, I will show you just a few more things. We need to go ahead and draw a line there. It's not going to be a very good line. And we are going to think it's a linear fit, so we're going to go analyze linear fit. Okay, so it went ahead and drew the line for us. There's some good information, that little box associated with that linear fit. If some of you guys are already familiar with something called correlation coefficient. If it has a positive slope like this, the closer the correlation coefficient is to 1.000, the better. Negative slope, closer to some negative ones would be really better. Correlation coefficient 0.94, not the best. Okay, any questions about that? One more thing I'm going to show you about, because it's on your calculations. So pay attention. One of the things I didn't show you yet is to give it a title. Titles are very important. Usually it's Y versus X. In this case, it would be what? Density versus weight percent. Okay. I didn't label these like I should have. Weight percent, units of percent. Density would be units of grams per mil. Okay, got to fix all that stuff. Okay. So, well, yeah. Let me go ahead and show you this over here. This really bothers me. Because notice density, it just truncated my zeros. I'm like, dude, there was significance there. So if you want to tell it how many decimals or how many sig figs, you can go over to the column, do a right click, and do column options. Wait, let's try, it has to be column options. Oh, let's pick density. Okay, so you see here where it says options, okay, displayed precision, it's automatically doing it for me. If I want 3 sig figs, okay, I click sig figs and say 3, and it added them back for me. So you got to be smarter than, you are smart, but you got to tell it. It doesn't miss. Okay, those are all things. Okay, so let's see. So that was basically calculation 4, okay, under graphing. Calculation 5 is that black line, perform a linear regression. Okay. Notice item number 5 in your calculations, to get full credit, okay, it all makes a difference. Every time you do a graph, I need 2 things, and they're both up here. Sometimes students put these 2 things on one paper, sometimes they turn it into 2 separate papers. I need this, the ordered pairs, and I need a picture of the plot. Okay, so that's what 5 says. So 6, remember that was calculating the density of your pop over there. That was 6. Now the coup de grace number 7 is where you guys are going to use this curve and the densities you got from that pop to calculate the weight percent of sugar in that pop. So the diet one, what do you think the weight percent of sugar is going to be kind of low or kind of high?
Compared to the other one?
Yeah.
Probably lower.
Probably lower. Mm-hmm. And I would even go out on a limb. Remember I said that I really pay attention to the last part in your summary where you results and discussion. That's where I turn my attention. The experimental is important too. But the results and discussion, I would, by golly, go ahead and go out on a limb and say which is which over there. 1 or 2. I'm going to label those 1 and 2, left to right. Okay, so here's the deal. There is a good chance that, let's see, there's a good chance that you're going to come up with a density of a solution that is about the density of water. Diet, maybe? Okay. And then there's also a good chance that you're going to come out, for instance, with one that is, let me kind of pick on the curve now. Let's say you came up with one that was a density of 1.15. Let's say the density of your unknown 2 is 1.15 grams per mil. Calculation 6, 1.15 grams per mil. Calculation 7 says, use this graph, and I think it's best to use Logger Pro. But if you weren't going to use Logger Pro, we could go ahead and use this graph to pick it off. Let's see, what did I say, 1.15? So this is 1.1, this is 1.2, here's 1.15, right? What you do is use this as what we call a calibration curve. So what we do is go over here and see where it intersects, and that's your weight percent. Does that make sense? So I said right here, where it intersects, go down here.
No, that was 1.2.
Oh, thank you. I don't know if I can erase it. I should have drawn it right here, right? Pick a different color. Right here, thank you. That's 1.15. So see where it intersects and come down. So if you want to do it this way, that's cool. But I'm going to show you how. If you have Logger Pro already up, we're going to make Logger Pro do it. But what would you say the weight percent is? 16? I would too, yeah. Say 10, 12, 14, 16, 18. Wait, I'd go 12, 14, 16, 17, about 17%. Does that make sense? Okay, does that work for you? Okay, so how do you let Logger Pro do it? Well, you go back in here to Analyze, the same place you put your line, and you go into Interpolate. Now there's Interpolate and Extrapolate. The difference is Interpolate says, like we have, that you assume that your point is on the curve, or on, your point is encompassed by the point of interest is encompassed by the data points. So notice I put my little hashtag there-ish, okay? And I'm at a density of, oh, I guess it's down here. Let's follow that line up. Density going up and up and up and up. So we set a density of 1.5. 1.15, thank you. All right. There-ish. Okay, so my dot is there, and it's coming down and showing, with that density, it's weight percent about 17.5. So you can let it do that work. And if you, I think there's a way you can screen capture this if you want to, or just hand draw it in. Any questions? So I'd ask this in the form of a question, but you guys know that I really want, in your results and discussion, you guys to say something about those unknown 1 and 2 back there. Okay? Like which one's which, and a good thing also in your summary here would say, bring in calculation 6. So the weight percent of unknown 1 was, 0.990 or something grams per milliliter. I said weight percent, sorry, the density. The density of unknown 1 was blah, the density of unknown 2 was blah, therefore blah. I conclude 1 is diet and 1 is regular. Any questions? Okay. Let me know if you have any questions as we go.